To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
So, my dear children, within the previous chapter, we have discussed some certain things related to the hydrocarbons lesson. Over there, we discussed the common formula of an alkane, and we discussed an alkane is a chemical substance or else an hydrocarbon that contains only single bonds between the carbon atoms. Now, my dear children, we are going to discuss further things related to the hydrocarbons. Especially in here, we are discussing about the alkanes now. So, we are going to discuss further things regarding the alkanes. So, you are given with an assignment then. So, using the common formula, derive the formulae of alkanes that contain carbon atoms from 1 to 5. So, now you have to derive the formulae of alkanes that contains carbon atoms from 1 to 5. Okay. So, let's derive then. First of all, carbon 1. Then hydrogen is equal to 1 times 2 plus 2. Right? 1 times 2 again plus 2. So, equals to CH4, which is also called as the methane. Right? Number 2. So, second one, now 2 carbon atoms. So, hydrogen is equal to 2 times 2 plus 2, C2H6, C2H6. This is ethane, right? This is ethane, C2H6. Then number 3, third one, carbon 3, hydrogen 3 times 2 plus 2. 3 times 2, 6. 6 plus 2 is equal to 8. C3H8. Next one, number 4. Carbon 4, hydrogen 4 times 2 plus 2. C4H8 plus 2, 10. Number 5, the final one, C5, right? Hydrogen is equal to 5 times 2 plus 2. So, 10 plus 2 is equal to 12. Carbon 5, hydrogen 12. So, these are the chemical formulae from carbon 1 to 5 of the alkanes from carbon 1 to 5. The basic hydrocarbon or the basic alkane, CH4. Second one, C2H6. Third one, C3H8. C4H10. C5H12. I think you can see a pattern. See? 4, 6, 8, 10 and 12. Then next one, 14. Next one, 16. Next one, 18 and so on. So, here you can observe an arithmetic progression. Right? An arithmetic progression can be observed when you see the structures or when you see the chemical formulae of these alkanes, right? The hydrogen atoms are arranged as a, right? Hydrogen atoms in here are arranged as what? These things are arranged as an arithmetic progression, my dear children. 4, 6, 8, 10, 12. Then the next one is 14, next one 16 and so on. Okay, right. So, my dear children, this is the assignment. So, we derived the formula, the chemical formula of the first 5 alkanes starting from carbon 1 to carbon 5. Right. Then let's head on to see what are the other contents in the lesson. So, alkanes, once again we are discussing about the alkanes. So, here it is given a fuel, petrol or gasoline is a mixture of alkanes. The most abundant alkane in it is the octane, represented by the formula C8H18. So, gasoline contains several or different kinds of alkanes. The most abundant alkane contained within the petrol is octane. So that is why it is go by the name like octane 92, octane 91, octane 95 and so on. Okay, it represents the amount of octane, right? So a fuel, petrol or the gasoline, is a mixture of alkanes. The most abundant alkane in it is the octane, represented by the formula C8H18. So the chemical formula for octane or petrol is C8H18. It is also a type of an alkane, my dear children. Next one, LP gas, another mixture of alkanes, mainly contain alkanes, propane C3H8 and butane C4H10. Tables show the molecular formulae and the structural formula of the alkanes with carbon atoms 1 to 5. So, the name of the alkane is given methane or else methane. Second one ethane. Third one propane. Fourth one butane. And the fifth one pentane. Okay, so these are the main alkanes starting from carbon 1 to carbon 5. Starting from carbon 1 to carbon 5, these are the names of the alkane. So methane or methane is CH4. Ethane C2, can you remember? Then 2 more than that amount, H6. Propane, third one, C3, 6 plus 2, 8, H8. Butane, C4, H8, H10. 2 more than the previous amount, okay? Remember always. Next one, the final one, pentane, C5, H12. C5, H12, right? So these are the molecular formula for the alkanes given in here. Methane or methane CH4, ethane C2H6, propane C3H8, butane C4H10, pentane C5H12. So my dear children, these are the molecular formulas and the name of the respected alkane. Okay, remember all of these substances contain single bonds between carbon atoms. Single bonds between carbon atoms. That is why these things are referred as alkanes, my dear children. Okay, right then. Now let's head on to see the next content. Then you are given with the table. Here you need to complete the structural formula for each and every molecular formula which is given over here. First of all, we'll write down their names, my dear children. So CH4, methane. C2H6, ethane. C3H8, propane. C4H10, butane. Final one, C5H12, pentane. So how to draw their molecular structures? Very simple, my dear children. First of all, you take the number of carbon atoms present in each, right? Number of carbon atoms present in each of these substances. First of all, you take that thing. So I'm about to divide the sections first. Okay. Right. Now let's okay. Now this is the table, my dear children. So let's divide into sections like this, and we'll separate the table, columns and the rows separately. Right, now let's draw the structures. So you know that methane is a very simple structure. It contains only one carbon atom and all the others are hydrogen. All the things are having single bonds. So it is like this: carbon, 4 single bonds. Okay, carbon and 4 single bonds, hydrogen, hydrogen, hydrogen and hydrogen. Methane. Right, then my dear children, the next one. Okay, ethane. So in ethane there are 2 carbon atoms. So draw 2 carbon atoms, 1 and 2. Make the bond between carbon atoms as single bonds like this. Now you know that carbon can create 4 bonds. Okay, so in order to complete the 4 bonds, you put hydrogen atoms around each and every carbon atom. Remember, carbon should create only 4 bonds. Okay, now here within this carbon it has created a certain type of a bond with this carbon. So this particular carbon can create like another 3 bonds here, here and over there. So here we go, 1, 2 and 3 bonds. Then once again for this one, 1, 2 and 3. So this is ethane. This is ethane. Then propane, 3 carbon atoms. You put 3 carbon atoms, then 1, 2, 3. Make the single bonds as these are alkanes. Now, in order to have 4 bonds for each and every carbon atom, complete the diagram by using hydrogen bonds. Right? So, 1, 2, 3. Now 1, 2, 3, 4, 4 bonds are completed. For this carbon there are 2 bonds already. So you need to put only 2 hydrogen atoms, 1, 2. In here for this carbon there is only 1 bond. So you need to complete another 3 bonds, 1, 2 and 3. Here we go. So this is the structure. This is the structure for propane. It's very simple to draw, my dear children. If it is an ane, that means alkane, you get the number of carbon atoms, draw single bonds among the carbon atoms. In order to have 4 different bonds or 4 bonds between each and every carbon atom, complete the rest by using hydrogen atoms. Okay, very simple. Next one, butane, C4. Ignore about the number of hydrogen atoms. Only thing that we need is the number of carbon atoms. So you get the number of carbon atoms completed by using single bonds. So let's go ahead. 1, 2, 3, 4. 4 carbon atoms. As it is an ane, all the things are single bonds. Now go ahead and complete the rest by using hydrogen atoms so that each and every carbon atom has 4 different bonds. So this carbon already created 1 bond with the nearby carbon atom over here. So it can create furthermore 3. 1, 2, 3. This one has created 2 bonds at the either sides. So it can create another 2, 1 and 2. Right? Here also there are 2 already. So it can create 2 more. The final one over here created only 1 with the nearby carbon atom. So it can create like 3 now. 1, 2 and here we go, the third one. Right. Then the final one, pentane. Carbon count is 5. So 5 carbon atoms. 1, 2, 3, 4 and 5. Single bonds. Now complete the number of hydrogen so that each carbon atom contains 4 different bonds. So here this carbon contains only 1, so means that it can create 3 more. 1, 2, 3. Here 2 more. 1, 2. Again 2 more. 1, 2. Again 2 more. 1, 2. Then finally here 3. 1, 2 and 3. Now my dear children, let's check whether our hydrogen count is correct or wrong. Now there should be 12 hydrogen. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. The previous one. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 4, 4, 8, 10. The previous one. 3, 6, 8, 2, 4, 6, 4. Can you see? It's very simple to draw out the structure. You just take the number of carbon atoms, combine all of these things with single bonds, complete the rest by using single bonds between carbon and hydrogen, so that each carbon atom can create, or each carbon atom would create 4 different bonds. Very simple to draw the structure. Okay, right my dear children. So these are the structural formula related to each and every molecular formula of the alkanes, right? So these are the alkanes then, right then. So you are given with an activity then, make models of the alkanes with carbon atoms 1 to 5 with the help of your teacher using suitable materials. So here now you can use, in creation of these things, you can use like regiform, right? And you can use different kinds of plastic bowls or else marbles, right, when making these structures, my dear children. So I hope that you will do these things at your school with your friends and with your teacher, right? So this would help you to guide and help you to remind the structural formula and as well as their molecular formula. So my dear children, I hope that you will look into this and you will follow up these assignments and activities at your home or at your school in order to memorize the molecular formulas and the structural formulas of the alkanes. Okay, right then. Now let's head on to see the next content. So for extra knowledge, for C4 and H10 and also for C5 and H12, the following structures are also correct in addition to the structures given in the table 14.2. Now this is the table 14.3. The previous one was the 14.2 table. So the molecular formula is given as C4H10. So instead of a linear arrangement, you can write this thing as a branched one like this. So 3 carbon molecules together, then 1 carbon molecule at the middle, then complete the structure like this. Then C5H12, it's like this. In the same way, 4 carbon molecules, 1 to the upside or 1 from a different location. Then to have each and every carbon atom 4 different bonds, hydrogen is being put down to the structural formula. Then in here also, my dear children, you can observe, now in here, from the middle carbon atom, there are 2 other carbon atoms which have been bonded. Now, as you can see here, this carbon haven't got any hydrogen molecule, haven't got any hydrogen element, as all of the carbon atoms, right, all of the 4 bonds are bonded with carbon atoms. Okay. So, however, if you check the count of the hydrogen atom, irrespective of the number of carbon atoms, the hydrogen atoms contained within the structural formula is same, because all of these things are called as, like equal structures. Okay, These things are called as equal structures for the previous one which we have took in the previous table. So these structures are also same or similar to the structural formula of the previous ones. So this C4H10 is the butane, C5H12 is the pentane. So these structures can also be used instead of pentane structure and the butane structure which we took like in the earlier here. Okay, so here we have took linear ones, but over there are like branches, several branches. See, a branch, two branches, right? However, my dear children, even though they have been branched, see, all the structures are having single bonds between carbon atoms. So therefore, all of these structures are alkanes. Okay, all of these structures are alkanes, my dear children. Remember that. Right then. Then we are going to discuss about the alkenes. So we have discussed about the alkanes, my dear children. Now it's time to discuss about alkenes. So alkenes are given by the common formula CnH2n. That means the hydrogen count is exactly twice as the carbon count. Okay. Now let's see what are alkenes. In alkenes, right, in alkanes, there are only single bonds between carbon-carbon atoms. So in alkanes, my dear children, there are only single bonds between carbon-carbon atoms. Also, there are hydrocarbons having double bonds between carbon-carbon atoms. You know that carbon can create 4 different bonds. Means that when bonding carbon with a nearby another carbon atom, there can be double bonds, right? There can be double bonds too. So, the carbon, if the carbon-carbon atom contains, carbon-carbon atoms contains double bond between them, then my dear children, these kinds of structures are referred as alkenes. Okay, alkenes. Okay, alkenes. ENE, alkene, double bonds. ANE, alkane, single bonds. The hydrocarbons of this type with one or more double bonds between carbon-carbon atoms are classified as alkanes. Right. So, my dear children, here there is a small bit of a mistake. Now, in your textbook, I think in the like newer versions of the textbook, sometimes they have correct versions. I mean, like there are corrections, there are wrong things, or the wrong these like of this kind of errors, especially mistakes regarding the words, and sometimes we can observe some kind of letters which are missing and spelling mistakes. So over here also, within the older book, right, within the first edition of the book, there's a small bit of a mistake. So this mistake is over here, they're saying that the hydrocarbons of these types with one or more double bonds between carbon-carbon atoms are classified to as alkanes. However, it's not alkanes, my dear children, it should be alkenes. Alkenes, right? So most of the times if you are having newer editions, right, then my dear children, you can observe the alkene word, right, because they have recorrected it when you are coming into the newer versions. However, in the older version, it is given as alkane, okay, not alkene but alkane. So it's not alkane, alkane we studied earlier, it should be alkene, okay. Older versions should have this word. So therefore, it's not correct, my dear children, it should be alkene, okay, right. So there's a small bit of an error in the previous version, right, in the previous versions, which is the first print. Right, so the hydrocarbons of this type with one or more double bonds between carbon-carbon atoms are classified as not alkanes, but my dear children, alkenes, okay, alkene. The molecular formula of the simplest alkene, ethene, is C2H4. So you know that in order to create a double bond between carbon-carbon atoms, there should be at least 2 carbon atoms. So there are no any alkenes that contains only 1 carbon atom. In order to have a double bond, there should be at least 2 carbon atoms. So therefore the simplest alkene is C2H4, which is called as ethene. Ethene is very important to us. So we'll be deriving several derivatives by displacing hydrogen atoms in ethene. These things are called as derivatives of ethene. So we'll be discussing those things when you go further with the lesson part. Right. So the molecular formula of the simplest alkene, ethene, is C2H4. Its structural formula is given below. Now let's draw the structure of ethene. So I told you that ethene contains a double bond like this. Then all the other bonds are single bonds. 1, 2, 3 and 4. So this is ethene. 4 hydrogen atoms with the double bond between 2 carbon-carbon atoms. Okay, right. So this is the structure of ethene. So as ethene contains a double bond between them, right, between the carbon-carbon atoms, this is called as an alkene. Okay, alkene. And the common formula CnH to the power CnH to the power H2n. Okay, CnH2n. So here 2 carbon, 4 hydrogen, 2 times of carbon, 2 times 2, 4. Right then, due to the presence of double bonds between carbon atoms, alkenes are more reactive than alkanes. Now my dear children, because of having these double bonds can be broken down. Okay, upon providing energy, we can break out this double bond. And because of that, my dear children, these alkenes are more reactive than, like they can break the double bond and they can bond with other substances quite fast. Okay, so therefore these alkenes, they are more powerful, they are more reactive than alkanes. Okay, they are more reactive than alkanes because of having this double bond. Okay, because of having this double bond. Then my dear children, alkanes are the ones that carries a single bond between carbon atoms. Alkenes are the ones that carry double bond between, at least 1 double bond between carbon-carbon atoms. Then alkynes, the third one. Okay, that thing is not given in your textbook. However, I'll introduce to you alkynes, right? Alkynes, ALKYNES, right? Alkynes. Alkynes are having at least 1 triple bond between carbon-carbon atoms. Triple bond between carbon-carbon atoms. Single bond alkane, double bond alkene, triple bond alkyne. Okay, alkyne. So alkynes are even more reactive than the alkanes or alkenes. So the most reactive hydrocarbon is the alkyne, which has triple bonds. Okay, right then. So now my dear children, we are going to study about derivatives of ethene. So we have studied about alkanes, we have studied about alkenes. Now my dear children, I have introduced to you what do you mean by the alkynes. So now it's time to discuss about derivatives of ethene. So we have studied the first or the 2 main categories of hydrocarbons, alkanes and alkenes. Even I have introduced to you what do you mean by an alkyne, right? So that's the end of the hydrocarbon part, my dear children. Now we are going to study about the derivatives of ethene. So we have studied about ethene, no? So now we are going to study about derivatives created by ethene. So the compound derived by the displacement of a hydrogen atom in ethene by a chlorine atom is called chloroethene. So the first derivative of ethene is chloroethene. Okay, chloroethene. So like I said, when I'm going to start this lesson part, my dear children, can you remember we discussed that we are going to displace several hydrogen atoms contained within a certain alkene and we are going to create derivatives of them. Okay, derivatives are the ones which are getting created by displacement of hydrogen atoms contained within a certain alkene. Now in here we are using ethene molecule. So the first and foremost derivative of ethene is chloroethene. So chloroethene is created by displacement of a hydrogen atom in the ethene molecule by using a chlorine atom. Right? By using a chlorine atom, we are going to displace only one hydrogen atom contained within chloroethene. Okay? Then the formula of chloroethene is C2H3Cl and its structure is given below. So the structure of chloroethene now. How to create the chloroethene? Now you know that this is an alkene. Okay, this is an alkene. So first of all you draw ethene molecule. You put the double bond between carbon-carbon atoms. Then you know that there are 4 hydrogen atoms as the alkenes are going with the common formula CnH2n. So this is ethene. Now what you have to do, you have to displace one hydrogen atom. You can displace any, right? However, only one. Any hydrogen atom out of these 4. Okay, displace that hydrogen atom by using chlorine atom. So erase one hydrogen atom, then displace it by using chlorine. So this is chloroethene. C2H3Cl. C2H3Cl. This is chloroethene. Okay, very simple, my dear children. You just need to displace one hydrogen atom with chlorine. That's it. So this is chloroethene. Right then. Then next one, tetrafluoroethene. Tetrafluoroethene. So it goes by the name fluoro, means fluorine should be there. Let's see. Compound derived by the displacement of 4 hydrogen atoms in ethene by 4 fluorine atoms is known as tetrafluoroethene. So like I said, my dear children, here we are going to displace hydrogen atoms by using fluorine atoms. Specialty is here we are going to displace all 4 hydrogen atoms, right? We are going to displace all 4 hydrogen atoms. We are going to remove all 4 hydrogen atoms and we are going to, instead of the hydrogen atoms, we are going to combine, right? Or we are going to create, right, fluorine atoms instead of hydrogen atoms. Okay. So formula is, the chemical formula or the molecular formula is C2F4 and the structure is as follows. Very simple, my dear children. You just need to displace hydrogen atom with fluorine atoms. So instead of H, the symbol F comes. Very simple. So this is ethene. So instead of hydrogen, you mention the symbol F for fluorine. So this is tetrafluoroethene. Tetrafluoroethene. Very simple, my dear children. 2 carbon atoms bonded with a double bond and 4 fluorine atoms, same as ethene, but however in ethene there is hydrogen, no. Now in tetrafluoroethene you can observe 4 fluorine atoms. Okay, so this is tetrafluoroethene. tetrafluoroethene. Right then. So we have studied about two derivatives of ethene. Number one, chloroethene. So what is the chemical formula for chloroethene, my dear children? Chloroethene, C2H3 and 1 Cl atom, C2H3Cl. Then tetrafluoroethene, very simple, C2F4. Then the structures, carbon, double bond carbon, one chlorine atom, all the others are hydrogen. There are 4 hydrogen atoms in usual ethene molecule, right? However, when you displace one by chlorine, there is only 3 and 1 chlorine atom, like this. Then the next one, tetrafluoroethene. In tetrafluoroethene, 2 carbon atoms bonded with a double bond. Then, my dear children, 4 fluorine atoms like this. 1, 2, 3 and 4 fluorine atoms. Tetrafluoroethene. Tetrafluoroethene. Okay. So, this is tetrafluoroethene. Right then. So, chloroethene, C2H3Cl. Over there you can observe the structural formula. Tetrafluoroethene, C2F4. This is C2F4, the structural formula. Okay. Right then. Ethene and derivatives of ethene are used to produce the polymers that we use in our day-to-day life, such as polythene, styrofoam and Teflon. Now, my dear children, about the polymers. So, these substances are used to create polymers in our day-to-day life. Polymers are large molecules which are created by the combination of large number of smaller molecules. It's like creation of a starch molecule by the combination of large number of glucose molecules. You know that starch is created with the help of glucose. We don't know actually how many glucose molecules are contained within starch. By the process called polymerization. Polymerization means joining of these smaller molecules to create a very large molecule. So, by the process of polymerization, starch is getting created with the help of glucose. Okay, with the help of glucose. So, my dear children, in here, right, the same procedure is going to happen. However, these things are carried out artificially. That means these things are carried out by humans. So, to create different kinds of artificial polymers, right, artificial bigger molecules, we use these structures which are called as, right, chloroethene, ethene and tetrafluoroethene. Okay. So, by using these special structures or special molecules, we can create, right, we can create polymers. Okay, we can create polymers which are larger molecules. Now, let's head on to see how to create polymers by using these substances of ethene. Right then. So, polymers. Pay your attention to the following pictures. Plastic goods, toys and clothes. So, when you take these things, my dear children, especially polythene and plastic, these things are, right, made up with polymers. These things are made up with polymers. So, here, let us inquire into the chemical nature of the material shown in the above pictures that we use frequently in our daily life. At molecular level, they all have a common special feature. That is, they all are made up of large molecules arranged in the form of long chains. Now the specialty here is that, my dear children, these things are arranged in long chains. Okay, they are arranged in very long chains. Like I said, these are very large molecules, right? However, these long chains or very large molecules are created with the help of small molecules. So very large count of smaller molecules joins together to form a very large molecule. Okay, very large number of smaller molecules in very large count joins together to form what? Those things are going to join together to form a very large molecule. So such a process is the one which is referred as the polymerization. Okay, polymerization. So through the polymerization of smaller molecules, a polymer molecule is getting created, right? So here, another specialty here is that most of these long chain molecules are composed of repeating smaller molecular units. Repeating units. That means, my dear children, when you take these larger units or larger polymers, they are made by repeating certain unit together. Okay, large number of molecules, right? Large number of same molecule is going to repeatedly bond each other to create this very large molecule. Thus, the molecules from which they are made are called polymers. In this lesson, let us discuss about polymers then. So, the smaller molecules which are going to join each other to create polymers, right? That's a specialty among the polymers, my dear children. Smaller molecules are the ones who are creating polymers. Okay. However, there are large number of smaller molecules, okay, which are going to repeatedly join in creation of polymers. Now, within this lesson, we are going to discuss the polymerization process. Okay. Now, let's head on to see the polymerization. So, large molecules formed by joining of a large number of small molecules with one another are known as polymers. So, like I said, my dear children, here a very large molecule is getting created by the combination of smaller molecules, okay, by the combination of large number of smaller molecules together. This large molecule is created by the combination of smaller molecules. For an example, let's take a gold chain. Okay, let's take a gold chain. A gold chain is created by one singular, okay, or else one single circular structure. Okay, one single circular structure. So these circular structures are joined together in order to create a gold chain, right? Now, within this figure also you can observe that kind of a structure which is made by file clips. Let's see what are the other contents then. The process of forming polymers is called polymerization. So, as we discussed, the process of creation of polymers is referred to as polymerization. This is the bonding process of different smaller molecules together to create a large molecule. Okay. Then, the small molecules forming polymers are known as monomers. Monomers. The smaller molecules which are being used to create polymers are referred to as monomers, my dear children. Monomers. And the large molecules formed by the polymerization of monomers are referred to as polymers. So, after the polymerization of monomers, right, polymerization means joining process of these smaller molecules which are also referred to as monomers, the polymer is getting created. Okay. So, polymer is the very large molecule. Pay your attention to the chain formed by joining some paper clips together. So, as you can see here, these are paper clips which are joined together, right. So, there are several number of paper clips. So, this entire one can be referred to as a polymer. One single file clip, that's the monomer. Okay. So, this entire chain has been created by the usage of monomers, and the chain itself or this whole unit is the one which is referred as the polymer. right? Okay then, the single paper clips used to form the above chain are analogous to the monomers, and the chain of clips is equivalent to the polymer. So like I said, my dear children, one single file clip equals to the structure of monomer. The entire unit created is equal to the structure of a polymer. Okay, then the basic structural units contained in the chain after the formation of the polymer are referred to as the repeating unit. So repeating units are the ones which are keep repeatedly bonded, right, in creation of a polymer. In here you can see that green color one, pink color one, green color one, pink color one, green color one, pink color one, then green color, pink color, like that it's going to travel to the end, right? So these structures, these are the ones which are called as repeating units. Green, pink, green, pink, green, pink, green, pink, the repeating ones. So these structures are referred to as the repeating units. So a polymer is made by repeating units. So the structures which are contained within the polymer, the structures which are getting repeated within the polymer, right, within the polymer molecule, in order to create the polymer molecule, is called as a repeating unit. Repeating unit is somewhat different than the monomer, somewhat different. Okay, there's a small bit of a difference between the repeating unit and the monomer. We'll be discussing about those things when you go further with the lesson part. Up to now, you just remember there's a small bit of a difference between the monomer molecule and the repeating unit. Okay, right then. So the molecular mass of monomers is relatively low. So when you take the monomers, the molecular mass is relatively low. You know that when you take CH4, right? When you take CH4, methane, the molecular formula is like 12 plus 4, 16. Okay, when you take, now we are discussing about derivatives of ethene, no, and we can create polymers only by using ethene. Within this lesson, we'll be discussing about only ethene based polymers. Okay, only ethene based polymers, mainly the structures, and also we'll be discussing about another special one called as the isoprene, who is going to create the natural rubber. But most of the times, my dear children, within this lesson part, we'll be discussing about derivatives of ethene and the polymers created by the derivatives of ethene. Okay, so here we have to use ethene, no thing. So when you take the ethene, right, ethene has 4 hydrogen atoms and 2 double bonded carbon atoms. Okay, 2 double bonded carbon atoms. So my dear children, when you take the relative molecular mass of ethene, 12 plus 12, 12 plus 12, 24, then there are 4 hydrogen atoms, 1, 2, 3, 4, then altogether it becomes 28. So relative molecular mass of ethene molecule is equal to just 28. 2 carbon atoms, 12 times 2, plus 4 hydrogen atoms, 1 times 4. So 24 plus 4, altogether 28. Right then. So the molecular mass of monomers is relatively low. However, the relative molecular mass of polymers formed by the polymerization of large number of monomers has a very high value. So my dear children, this is a monomer now. Let's take that this one as ethene. So 28. So how many 28s are there now? 1, 2, 3, 4, 5, 6, 7. In here, just 7. It can be even more, right? We don't know the number of units which are contained within a polymer. So when you take a polymer, my dear children, their molecular mass is very high because there are large number of smaller monomers. Right then. So then these are the polymers, my dear children. Right. Now we are going to discuss about some common polymers that we can observe within the environment. Common polymers. First and foremost polymer that we are going to discuss is polythene, right? Polythene. This is also called as polyethylene. Polyethylene. That means this is made by using ethene molecule. That is why it is called as polyethylene. Polyethylene. Right. Consider the ethene molecule we learned earlier. Let's see. This is ethene. Carbon. Two hydrogen. Sorry, not hydrogen. Double bonded carbon atom. Another carbon atom. Then, my dear children, there are 4, 1, 2, 3 and 4. There are 4 hydrogen atoms. This is ethene. This is ethene. Now, what we need to do is, we need to repeat this ethene molecule so that it can create bonds. In order to do that, my dear children, what you have to do? You have to break this double bond. If you can break the double bond between carbon-carbon atoms, then what will happen? Then, my dear children, this particular carbon atom can also create one bond from this or whatever the side, okay? And also, this carbon atom could also create one bond between from any kind of a side, okay? So what will happen if I'm going to break the double bonds between hundreds and thousands of molecules of these ethene? Then, my dear children, definitely all of those things will join together to create a very large molecule, as they are going to lack a certain bond over there. I mean, in simple, like this. This molecule, I'm going to arrange it like this. I'm going to break the double bond in here. That means this particular hydrogen now has created only 1, 2, 3 bonds. Means from this side it can create another bond. This carbon atom also has created, see, 1, 2, 3, only 3 bonds. That means from this side, this carbon atom also can create another bond. So when you multiply or when you get like hundreds of these molecules together, all of these 100 molecules joined as a linear, right, line or linear heavy molecule, all of those things are going to join together as a linear heavy molecule to create a polymer. Okay, this is the one which is referred as a polymer then. So making a polymer is not that much difficult, right? It's very simple, my dear children. What you have to do, you just take several bonds, right? You just take several double bonds between these molecules and break it down. Then, my dear children, the units which are created after the breaking down of double bond will join together to form a polymer. So this is how the polymers are created, my dear children. So I'll erase this part and let's head on to see the next content then. So this is ethene. Now let's see how to get polymers by using ethene. So polythene or polyethylene. Polythene is produced by polymerization of ethene molecules. What happens here, of the double bond, one bond breaks and thousands of ethene molecules are added together as shown below. So here you can observe 1, 2, 3, 4. There are 4 ethene molecules. All of these ethene molecules, they have completed structures. Now what we are going to do is we are going to break the double bond between carbon-carbon atoms. Then what will happen, my dear children? Upon breaking the carbon-carbon atoms, each and every molecule will join together now because they lack a certain bond. Okay, so this entire molecule, now it is an entire molecule. There are no any distinct ethene molecules like this. If it is a distinct ethene molecule, then my dear children, it would have a double bond between carbon-carbon atom and with 4 different hydrogen atoms. However, now you can see that when you come to when you are going to downward line, like in here, you can observe that the double bond between carbon-carbon atoms has been broken down. Okay, it has been broken down. And these carbon atoms now joins together. So this entire unit now behaves as a one single unit. Okay, the entire system now it is going to behave as one single unit. This is the one which is referred as the polymer. Okay, as it is created by using ethene, this polymer is referred to as polyethylene, which goes by the name polythene. Polyethylene is the one which is referred as polythene. Okay, why it is named as polyethylene? Because it is a polymer. How did we create a polyethylene, or how did we create the polymer polyethylene? By breaking the double bonds of an ethene molecule and joining these units like thousands of units together. Right? This process is the one which is referred as the polymerization. Right then. So, the above polymerization process may be summarized and indicated as follows. So, let's indicate it. First of all, this is ethene. So, we take ethene and we break the double bond to create this. This is called as the repeating unit, my dear children. The repeating unit. Then, n number of these repeating units join together to create the special structure called the polymer. So the n number, right? We don't know how many molecules are there. So that's why we are going to put that n thing. Okay. So this is the way of creating a polymer. So there are n number of units contained within a polymer. We don't know actually how much is it. That is why we are giving that term as n. So here it is given. This means that n number of ethene molecules link with one another and create a polythene molecule with n number of CH2 repeating units. See, CH2 bond CH2. See, CH2 bond CH2 repeating units. This is the one which is getting repeated then. CH2 units, repeating units. So this is the one which is referred as the repeating unit. Right? Repeating unit. This is the initial structure or the initial molecule used to create the polymer. This is called as the monomer. And over there, you can observe the large molecule which is called as the polymer. Right? So, monomer, the simplest structure or the simplest molecule used to create the polymer. Repeating unit, that is the molecule which is created to repeat which is created by the breaking down of double bond in order to repeat. Then the polymer. Polymer is the structure or the molecule, the larger molecule created by the combination of large number of repeating units. So this is the structure of polythene, my dear children. Okay, the structure of polythene. Right then. So you are given with an assignment. Make a polythene polymer molecule linking appropriately the models of the ethane molecules you have made in assignment. Right. Now let's see what is the assignment, my dear children, once more. So what you have to do, you have to make a polythene polymer molecule linking appropriately the models of the ethane molecule you have made in the assignment. Now in the previous assignment, I think you can remember, we discussed and I told you that we need to follow up with the lesson part and we need to make the structures regarding the hydrocarbons. Over there we created the ethane molecule. Ethane is like this, C2N, as it is N, all of these things are having single bonds. 1, 2, 3, 4, 5 and 6. Now, by using this thing, you have to create what? You have to create polythene. What do you have to do? Very simple, my dear children. If you displace this hydrogen, and if you can bond this kind of a structure to here and there, and when you create like n number of, large number of these kinds of molecules together, simply we can create polythene, right? It's very simple. This is how the polythene molecule is getting created in simply. Okay, what we have to do is you need to create this kind of a molecule by using the ethane molecule. Only thing that you need to do is you need to remove those two hydrogen molecules or the hydrogen atoms which are located at the sides. Then take the unit which is created after the displacement of hydrogen, like this. Now take like n number of these things together and joined like in the previous case. Okay, by that way, my dear children, you can create the polythene molecule, which is the polymer. Okay, so like this, what you have to do, you take another two, 1, 2, then do the bonding. Then for here also you take another two, 1, 2, then you take the bonding. Right, so there are like 1, then this is the second one, and this is the third one, and the cycle is going to continue, my dear children. Right, the cycle is going to continue. So I'll erase over here this hydrogen to continue the cycle. Right, so now the cycle is going to continue. These are the structures that can be identified within the polythene molecule, right? And these units are the ones which are referred to as the repeating units, right? Repeating units. So my dear children, I hope that, so I have given you the structure, so I hope that you will create this structure, a model of the polythene molecule by using ethane at your school or at your home. Okay, right then. So my dear children, we have discussed several things regarding to the lesson part, the alkenes, and we discuss about several lesson parts related to the polymers. So in our next chapter, we'll discuss even more things related to our lesson hydrocarbons and their derivatives. Okay, so within our next chapter, we'll be learning about several other types of polymers that we can observe within this lesson part. Okay, and also my dear children, we'll be discussing about uses of these special polymers, and finally we are going to discuss what are the disadvantages and the advantages of using these artificial polymers. Okay, right then. So I'm going to meet you with the next chapter to discuss these things. Okay, so I'm hoping to meet you with the next chapter then, my dear children. So it's time to say goodbye for this chapter then.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.